Hey, this is Prof. Hamilton. I'm going to take hopefully just about 10 to 15 minutes here to pretty quickly go through the answer key for Chapter 3. There's a couple things that I've updated talking with the student that I think there's a typo in one of the answers. So we'll get to that here in a little bit. So, all right, without further ado, question 1 is really just about first of all, using revenue, which is price times quantity, but then using different prices and quantities to find out how that changes with revenue. Um, so this is basically just plugging in. I wish they would write out rev or something, but yes, R is for revenue in this book's notation. Okay. Part C, you actually have to, if you extend this line out, you would see that it intersects the horizontal axis at 7. The marginal revenue curve for a straight demand curve is always going to start at the same vertical intercept and go down twice as quickly, so it'll hit halfway between 0 and 7 in this case at 3.5. So then that corresponds to a price of, let's see, where we go here? Oh yeah, okay, a price of 7, yes, I was looking at 14, yeah. So at this point, going up vertically, that's a price of 7 for the, where the demand curve would be unit elastic. So one kind of shortcut in some problems, okay? All right, number 3, you're given this nonlinear demand equation, which looks, it's one reason why a lot of times we just want to use linear curves, because it has a very intuitive proportional ratio for each of the inputs on the right-hand side. And this chapter 3 is, a little side note, probably the most one where calculus is sprinkled into it. So as I said in my intro, there's absolutely no need to know calculus or remember calculus if you had it. If you can remember first derivatives and a few things like that, that'll probably make some sense to you when we start talking about marginal. But reading this chapter is a little challenging because there are things about calculus or other, I think, regression analysis also. So, and we don't want to turn this into a quant course. We want to kind of start with the equations and in some ways have a more intuitive way of answering things rather than using optimization techniques, which are useful in their own right. But anyway, so we have this demand curve. Again, I don't have the whole equation here, but yeah, something like, yeah, log quantity equals 7 and then minus 1.5 log of its own price plus 2 times the log of a substitute price, substitute product, minus 0.5 times the log of M for income, and then plus 1 times the log of A for advertising, I believe. So the nice thing about this formula is that it's actually going to be a curved demand curve that has the same elasticity throughout. So unlike a straight demand curve where different points on it will have different elasticities, we can just look at the equation and pull those numbers. So that's what the answers are saying here. You just look at the, its own price. The coefficient on that was minus 1.5. It's elastic. Okay. One thing that this book does is usually it doesn't take the absolute value of the elasticity of demand, and most books or other places I've seen this will take the absolute value. So if it's negative 1.5, we'd say it has an elasticity of 1.5, with understanding that prices and quantities move inversely on the demand curve. But we'll see that too when we find the unit demand level. We use -1, not +1. Okay. All right. Anyway, back to this question here. Again, it's the nice thing about this, if you trust the math, so to speak, is you're just pulling coefficients off the associated variable. So the cross price elasticity is the coefficient 2. The income elasticity is minus 0.5. Okay, and then there's a 1 on advertising, so it's unit elastic. Okay. There's a couple of problems using this formula, and again, there's probably more intuitive ways of going about it, but basically this chapter derives this result, and it's kind of like, well, you have the tool in hand, or the equation in hand, to be a little more specific. If you can just plug in the various values, so 40,000 is the revenue of X, this 1.5 is the elasticity of X, then 90,000 is the revenue for Y, minus 1.8 is the cross price elasticity, and then there's a 2% change in the price. So at a kind of a get an answer level, it's just plug and chug, and I may come up with another way, as I'll show you later on, that we may be able to set this up in a spreadsheet that would kind of give us more trust for this equation. Okay. Number 11 is, let's see, the smartphone manufacturer. Okay. So here we're given a couple numbers. So the 108 is, so some of this is just language. It doesn't always say percentage change in quantity, but for this question, I think it said something to the effect there's a 108% increase in shipments. Shipments, quantity, okay. And then there's a 21% drop in the price, so that wasn't quite as word slippery as the first one. So we end up with about -5 elasticity, and that is, since it's less than -1, it's elastic. Okay? And then from that we can interpret how that will affect, that price change will affect total revenue. Okay. One thing in this chapter, and I even myself, I find in reading these questions, because there's elasticity of quantity demand, there's the cross price elasticity, there's income elasticity, so they're all looking at one thing changing and affecting something else, but it may be a good idea in the question to underline, oh, this is, in 14, it's income elasticity. So here we're given that is 2.6, that overall in the economy, income is going to rise by 6%. And what is that going to do then to the other missing part of our formula here? And we can see here that yes, since this is really multiplied, it's something as income goes up, it doesn't have just a proportional 1-to-1, it's a 2.6 to 1 response. So for every 1% increase in income, there's a 2.6% increase in demand for this product. So anyway, you can see the answer there. If it's 15.6, or excuse me, if it's a 6% increase in income, then there's a 15.6. Again, it's magnified because this is a luxury good. Okay. There's a couple questions, and this is one. Yeah, I'll go through a couple ways. So this is what I sent you originally. I've added a note here, and I'll repost this as well. That if you want, you can just pause the video here for a minute and read this. But it's this formula. It's really the elasticity formula, but in a little more I don't know, convoluted way of looking at it. So this is if we break down the formula, this is the percentage change in quantity from a percentage change in price. And we get that just from this formula right here. That is basically it's the slope, or the inverted slope if you switch the axis. That's going to be if price went up by 1, then quantity is going to go down by 1.5. Okay. And then the rest of the formula, so that was the deltas. Then this is price, which we just have as P. Quantity, we substitute in the demand curve in terms of price for that. So there's a bit of algebra, and you'll find going through that the price is 50,000. Let me show you another way, and I'll send you the link to this, and you can experiment around with yourself how to solve this. So this is the same question. Only thing you need to enter here is, well, it's already done in this case, the if you have this equation, enter in the intercept and the slope, including the negative sign, and then the rest is done for you. So we'll jump down here. Basically, it gives you a range. It kind of automates picking a starting price that's about 90% of what the true value is going to be. And so that's, I'll show you in a minute how I found that. But then we find the quantity from this equation right here, which again I've set up in Google Sheets. This dollar sign, you may or may not have seen that before, has actually nothing to do with money for once. It just locks in, because on all of these different rows, we want to, when I copied it down, I didn't want it to go to C4, C5, C6. I always wanted that first parameter. Okay. So we have a potential price. We use the demand curve to find the associated quantity. Revenue was just price times quantity. And then for 2 points, I find the percentage change in price using the price 2-point values. Likewise, I compare the associated 2 quantity values. And then elasticity is just the ratio of those two. So as we scroll down here, I think I have about 20 different options. Okay, you can see here it actually is maximized at 3.75 million. Same answer as we got before. That's at a price of 50,000. It's a little bit, just because of the kind of discrete nature of looking at 2 different points, it's actually -1 at 51,000, but that's going from 50 to 51,000, it's -1. Hopefully that's not too disconcerting that it's not -1 right there, but that's just how I'm comparing the lower value to the higher value, and that and the lower value at the maximum is 50,000, which is the optimal price. Okay. So yeah, you only have to enter in these 2 parameters, and the optimal price. This is just a general formula. It comes from calculus, but it's just says look at the intercept divided by -2 times the coefficient, and that gives you your optimal price. Okay. And the max revenue again is that price times the associated quantity. In this example, I hit it right on, but to set up this table, I just say, well, let's start now that we know the answer. You don't always have to have that. You could, when I first did this, I just tried, well, I knew the answer from the book was 50,000, so I started at 40,000, I think it was, and just ran down a range, adding 1,000 each time. But since we already know the answer, I just start at 10% below that, and then kind of try to pick an increment that would fit. Okay. Sometimes this won't hit exactly if you don't have a exact increment of say 1,000 or 100 or 10,000 if it's a really high-priced item, in which case you won't get the exact answer in the table, but it should cross over that value. So okay, so I'll send you this link, and also you can, I think it's problem 21, if you just change this to 207.5 and change this to -0.8, it'll do everything for you. So I'll just leave it as is. Okay. All right. So 16 is very similar to the one before, plugging in some revenue numbers. 21, this was the one where I sent you, hopefully you're not like angry because you couldn't. You're like, what is going on here? There was a couple typos. One is they had instead of minus 0.8 here, they had minus 0.9, and they also left out the minus 0.08 in the denominator down here. So that they worked it out right when they wrote it down, but when they typed it in, because this is the correct answer here, 129 and 69 cents. Okay, and again, you can use that spreadsheet, enter in 207.5 and minus 0.8, and you will see it's the optimal max revenue maximizing price is about 130. Okay, 22 and 23 weren't on the original homework sheet, and so but as I looked through them, I thought, oh, here's a couple of good examples without any math. So I think it gives you a little more experience of how we could use this. So yeah, one or two reminders. One is, again, no need to turn in the homework because, well, I'm giving you the answers. So I mean, you could just send this back to me if that was the case. It'd be a little suspicious without any edits. But so yeah, this is kind of a a big boy adult class where it's like, hey, I'm trusting you to do the work, and when we have a test, if you've done the practice and grappled with some of this stuff, which can be a little painful, but if you will overcome. Where I think it's much different. It's much easier to say, even if you see the answer and understand it, formulating the questions, finding out what information do I have, how can I put that together to find the answer. That's more challenging. So, all right, this is chapter 3. I'll have chapter 4 posted soon as well. But again, no online session this week. But we'll try to pick that up next week in some format. All right, take care.